All right, guys. So in this kind of part 2 of chi-squared homogeneity, we're going to do one more test for homogeneity. In this test, we're going to see what happens when we reject a null hypothesis and how do we conduct a follow-up analysis when we reject a null hypothesis. So for this example, a student decided to investigate the ways that to influence a person's behavior. Essentially what they did was they split the volunteers up, gave 20 red surveys, 20 blue surveys, and 20 control surveys to the volunteers. The questions were worded a little bit differently, and then at the end of the survey, they had those people choose whether they wanted a red candy or a blue candy to see if the surveys at all influenced their choice. So, for our significance test, does this data provide convincing evidence that the true distribution of color choice is different for our 3 types of surveys? Our null hypothesis is going to be that there is no difference in the distributions of color choice and what survey they were given. And for our alternative, we're going to have a similar statement, changing one word to say there is a difference. And for our significance level, we'll go ahead and use 5% as the alpha level. So let's go ahead and set up our test. We're going to be once again performing a chi-squared test. Once again, this test is going to be for homogeneity. And then let's go ahead and check our conditions. For randomness, it does say that they were randomly selected into groups, so we are good there. For our 10% condition, we can take 10 multiplied by our sample size of 60. Is it reasonable to assume that they could have found more than 600 volunteers to participate? And I would say sure. And last, we need to check that all of our expected counts are strictly greater than 5. So to do that, we're going to go ahead and start to type these values into our calculator. Remember, this is where we have to use the matrix meaning. For our first matrix, matrix A, we're going to let that be the observed values. So if you haven't already, go ahead and get those typed in. And then in matrix B, we're going to go ahead and calculate the expected values. I've got those here for us. Since it's the same number of surveys across the board, it's going to be the same expected values across the board for both red and blue. For red, that's 8.6 repeating. For blue, that's 11.3 repeating. And looking at those values, they are all greater than 5. So we are good to go ahead and continue with our test. So let's go ahead and conduct our test. We're going to be looking for what the test statistic is, what our p-value is, and last but not least, what our degrees of freedom are. So in our stat menu of our calculator, we're going to go ahead and go over to test and choose a chi-square test. Remember, just chi-square test, not the one for goodness of fit, because we're dealing with 2 variables here. And for that, we've already got our observed in both A and B, so we can go ahead and hit calculate. Here's going to be our chi-square test statistic, which is 6.65. Our p-value is 0.036. And our degrees of freedom in this case was 2. So for our conclusion, we're going to say that because our p-value of 0.036 is less than our significance level of 0.05, we're going to reject our null hypothesis. In other words, there is convincing evidence that the distributions of color choice and what survey they were given are in fact different. In other words, it does appear that the color of the survey had some kind of an impact on whether or not they chose a red or blue candy. So a follow-up analysis. Remember, we're going to do this anytime we reject our null hypothesis. We need to do a follow-up analysis. Now, you'll notice that on this screen of the calculator, it does not have a contributions list the same way that it was for a chi-square goodness of fit. So we're going to have to do a little bit more work to figure out what category it was that contributed the most to our decision to reject our null hypothesis.